A coil contains capital N turns of insulated copper wire of diameter simple d and resistivity ρ wound on a cylinder of diameter capital D. What is the total resistance between the two ends of the coil of copper wire? We can write the equation for resistance of a wire R equal rho L divided by A. Here L is the length, A is the cross-sectional area of the wire. To find the resistance, we have to know L and A. Cross-sectional area of the wire equal pi r squared. We know r radius equal diameter divided by 2. Then we can write cross-sectional area pi d squared divided by 4. Okay, next we have to find the length. Since diameter of the wire is very small compared with the diameter of the cylinder, we can take the diameter of the loop equals capital D. Length of one loop equal to the circumference of the loop, that is 2 pi r, then that is 5d is the circumference of the loop. Okay, then total length of the wire should equal to 5d means length of one loop. We have capital N turns, then we have to multiply by capital N. Okay, now we can substitute this L and A to our first equation. Resistance of the wire equal rho L over A. Rho L equals to 5dn. Cross-sectional area equal 5 simple d squared divided by 4. Then we have 4 rho in d divided by simple d squared. Okay, this is the resistance of the wire. So correct answer is A.